Okay, today we're going to build the 3D printed celebration robot. The idea behind this is that the robot dances and moves his body back and forth, moves his arms back and forth, his head back and forth, the eyes light. And you can hang different signs off the arms if you're so inclined. That particular one, of course, said happy birthday, anything you can think of, happy anniversary, going on vacation, gone fishing, be my Valentine's coming up, Happy New Year already happened, season's greetings. You can 3D print all kinds of different little signs to hang on the robot, and I'll run it without the sign there so you can see what's going on. Basically there are two AAA batteries, one inside each foot. There's a switch on the back, and when it's running, this is what's going on here. So you can see there's a cam that controls the legs and the feet and the head. And there's one change that can be made on this cam where when the body is tipped one way, the arms are going the other, or you can have the arms tipped the same way the body's going. So the one that we're going to be building in the gold filament here next, I figured we'd go ahead and put the cam in the other way, and then we can compare which one looks the best, the craziest, which one's the way to go. So basically, here are the parts. I'm going to move the camera. Well, we'll get to the parts one by one. I guess there's no reason to move the camera. Because the parts are all so small, the project actually prints relatively quickly. Doesn't take too long. We're going to start with the legs, the feet, the legs where the batteries go. And there's a right and a left, obviously. And they print flat on the bed of your printer as I'm holding them. You don't need any supports for here or here. You can bridge that. But you do need supports for this part. I use the Prusa slicer, which means you can put in support enforcers. So I put support enforcers here, and it just only puts the supports there, and only puts the supports there, so you're not wasting time printing a bunch of other stuff. Now the reason they're printed flat like this is your part's going to be stronger on something like a leg when the layers are laid this way. If you printed something like this as, say, one piece vertical, which you could do with no supports at all, but the problem is your layer lines are now this way, and the part is going to be more prone to snap and break. So we're going to end up gluing these parts together on the right and the left leg. And my glue preference for anything made in PLA, this is printed in PLA, is this stuff right here. See? The reason that this is better than super glues is super glue is just a surface glue. It's a liquid that becomes a solid. The only reason super glue holds anything together is that solid is supposed to permeate in the little imperfections of the surface, and then that is what holds it together. So eventually those little imperfections in the surface crack and let go, and the part falls apart. This actually melts the PLA parts together, much like a styrene glue and styrene plastic model kits actually melt the plastic together. And they're stronger once that has happened. In fact, if they break anywhere, it'll be somewhere where they weren't glued. The glued part is almost always stronger. So, let's see. Haven't had this opened in a while. If the nozzle's plugged, we may have to clear it. But if it's not, then we'll be good to go here. Okay, it looks like it's coming out okay. Just going to put some along here on this edge. Just like that. And I'm going to cap it so that doesn't dry up. And here we go. What you need is a table edge somewhere. Like I'm doing right now. Is that on camera? No? I'm using this edge of the table to allow this part that hangs down lower to go over the edge, but then I can push the part basically to make sure that it's very straight. And if you have it, you can then take some clothespins and just pin it together and then set that off to the side for a few minutes. And we'll glue this next one up. And while they're drying, we'll move on to another part. They don't take long to dry. It's almost quicker than super glue. Sorry, I can't look through the camera while I'm doing this, so I don't know what's on screen and what's not, but I believe you guys all know how to glue, so it's probably not too important that it be on camera. So again, a table edge is going to help you get them flat and straight. Grab a couple clothespins if you have them, like so. And again, I'm just going to do this over here. We'll let those set for a moment. We'll come back to them. I didn't actually get that one perfectly lined up, but it'll have to do. Here's the main body part. And this piece does print vertically. No supports required. It'll print just like that. And it'll come out. And it does have a front and a back. This piece that's coming down the back is where we're going to route some wires later. So this is the back. This is the front. To operate this toy, we're just going to use one of the standard TT type gear motors. If you get the fast RPM one, then your robot dances fast. If you buy a slow RPM one, then dances slow. So that's completely up to you. The two motor contacts where we're going to solder our wires on, I want those facing towards the back. So when we slide this in, you can see that this is the back view now. We have two holes where we can put some screws. Here in America, we can just use what's called a 632. The 6 is the size, number size, and the diameter, and the 32 is referring to the threads. It's just a very common screw. And this little short one, oops, and I won't even bother looking for it. Well, maybe I'll have to bother looking for it, come to think of it. But those type of screws can be found in wall switches and wall plug-ins. They all have screws in the side, so if you've ever replaced an old defective wall switch or plug-in, you can just grab them from there. Or otherwise, you can just go to the store and buy some 632 short, something maybe 3/8 of an inch long. Certainly no more than a half an inch. But they'll thread right into the T32 motor's housing. Be nice if they were a Phillips head instead of a common head, because it's easier to get them in there. And just snug those up. Like so. On the front, we're going to put two more screws later, but there's another piece that's going to go on there first, so we won't do that just quite yet. Okay, so let's go back to the feet. One of the trickiest parts of doing these feet is going to be the fact that we're going to put some battery connectors in there. And you can find, like at the dollar store, things that use AA or AAA batteries. You can just buy and rob these little spring-loaded battery connectors. Usually the negative end will have the spring load on it, and the positive end is just a flat with a dipple. You can also just buy these as battery contacts for like AA and AAA off of eBay and Amazon. They're not going to fit in. We don't really care what size they send you, because this metal we're going to trim with scissors. What I'm trying to get at is they're kind of a boxy square sign, and we've got a rounded area that these have to fit down into. So if they sat in there like that, sometimes they won't go all the way down and they would stick up a little, see? So I'm just going to take some scissors. This bottom tab I've already bent forward. Normally that little bottom tab would be sticking straight out. I'm just going to trim some of this metal off that way. Trying to do this and trying to stay in camera. I can't do both. Anyway, it doesn't cut very hard. It cuts real easy because the metal's thin. So now you got kind of an angle. So that's going to fit down in there. I'm not putting this one down in there yet. I just wanted to show you how we're going to trim them. I can take this one. I have one that I've already prepped with a black wire on it. And the reason I have a black wire is so that once I've run the wires up through the legs and the feet and the body, I'll know what was negative and I'll know what was positive. And the only reason that's important is because I'm using LEDs up in the head to light the eyes, and they have a polarity. The motor could run in either polarity and the robot would dance, so it doesn't really matter. If you're not going to put LEDs in your robot's eyes, then don't worry about the polarity. The two batteries are being wired in series, which means one battery, you know, you have a negative on one battery, goes to the positive touches the negative of the next battery, which goes to the positive. So instead of having 1.5 volts, you have 3 volts. So it's wired in series. I'm going to grab one of the legs. These hooped parts are the front of the leg. I guess I don't really need those on there anymore. Let's take those off. I want the, in my case, I like to have the negative side of the batteries to the back. See this the nice slot that's there? It goes all the way up to the top. So I'm feeding this one battery, spring-loaded battery contact that we just talked about in there like that. And I'm going to glue this one to the back of the leg. See, this would be the front of the leg. So this would be the back of the leg. And here you can see where I did a crappy job lining up the two pieces, kind of a little bit off on height, because I was trying to pay attention to the camera and not watching what I was doing. But it's going to work just fine. I'm going to put a little bit of E6000. E6000 is a good glue. Originally, back in the days, it was called Goop. But then too many other products came along, including beauty products, that use that word, so they changed the name to E6000. But it's one of the best glues you can buy when you're trying to join different materials, like metal to plastic, for example. And what I'm trying to do here is tuck this in to the back side. And I'm actually going to grab, a random AAA battery. And I'm going to shove it in there just to hold that in place while that glue kind of sets up a little bit. So you can kind of see what we're dealing with. And eventually I'll use the same process to glue the positive one in the front. Let's let this set for just a moment, and let's actually do a positive one on the other leg in the front. So again, I have the piece of metal prepped with a red wire on it so I would know it was positive. I gotta trim it so it'll fit down in there. Like I say, this is the hardest part of the whole project, and it's not hard. So if you're able to stick with it through this, you'll be able to breeze through the rest of the build, no problem. Put a little bit of the old E6000 on the back side of the flat, dipple facing in for the battery to push on. Grabbing the other leg, the front, is where we're going to put this, just because I like the positive of my batteries to the front and the negative to the rear. It doesn't really make any difference. So I'm going to take that and kind of work it down in there. And I don't have a spring load to push against it, but there. I theoretically could glue that spring load down in there, but I'm going to have to solder to it later. You know what? We're just going to set the spring load in there so it can apply tension, and then we'll lift it out later when the time comes to glue it and solder it. So I've just set it down in there, and I'm going to push the battery against it. That way it can apply pressure to this front one that we're trying to glue. We're going to let that sit for a moment. And while that's sitting, why don't we move on to another part. On the very top of the body, remember we already talked about this part of the body, and that this is the back. Here's this upper shoulder piece, and I've already screwed in a switch, which we'll end up soldering to. The only reason I did that was to save time of me trying to fumble with these small screws on camera. But this part that sticks down the back side of this thing, that's just going to go down like that. So this whole part fits on the body. This is the back. Here's the switch. Here's the front. What's going to hold this part on in the end is, well, there's two things. One, you could glue it. You could put some dabs of glue on this surface or on this surface, and when you push them together you can hear, or you could put a dab of glue here and here, and when you slide them together they'll stay. Or there's going to be some either screws or nails, and what I'm going to use and call it a pin nail, that have the arms that held together. You could, if you wanted to use screws, number 2 screws, just screw them down, and then if you have to take it apart, it's easy to do. But that's what's going on there. Okay, where are we at? We've got the one wire, since we said we were wiring the 2 batteries in the feet in series. So that means I got to run one wire from one leg clear over to the other leg. I've already prepped a positive end here with a wire so that we can do that. So we just need to glue that one in place, and I believe it's this one. It's the one that we glued the negative one in. Let's just take our little battery out of there for now and feed that wire through. In this case I picked a color that was just different than the red and the black, so it's kind of a pink tan color. But that's just going to be to connect the 2 batteries together in series. Put a little bit of the E6000 on there. There's a trough down inside this foot where the wires go. You'll see it when you print the part. So now we've got that on there. And this is a left foot. As we look at this build on your screen, of course it would be on the right side of your screen, but in reality it's the left. And fit it over that shaft in the front, and it should, if you've cleaned up all your, it should all line up there. I'm going to take, in my case, some nails. I've already cut them down so that when they go in, hopefully they don't stick more than halfway through, because I'm just going to drive them in both sides. In this case they fit a little bit loose. If you're doing the final assembly and you're sure everything was going to be okay, you could put a little drop of glue down in the hole. I'm sure I'm going to regret not gluing them right now. On the white one, I showed you at the beginning, I actually went in, because I knew I was going to be taking it apart probably a dozen times. I went in with some number 2 screws and just screwed them in. So you can still do that if you want to try to locate some number 2 screws. You might have to slightly enlarge the holes on the legs to make sure that they pivot easily on the screws, but the screws will then bite and go in to the body quite securely. What else? Let's see. I think I'm going to end up fighting those nails falling out of this part if I don't do something about them right now. It doesn't really, since they're just an axle, it doesn't really matter if they're glued into the body or if the head is glued onto the leg because they're fitting loose. So I'm just going to go ahead and put a little bit of the old E6000 near the head. I'm just going to let that bite into the leg just so that they're not constantly falling out during this build. This stuff should set up pretty quickly. It shouldn't take too long. There we go. Just a little bit of the old goop E6000 on there. And then hopefully that'll set up. Now on the other leg, you got to put them in the right order because these cam followers have to stack one on top of the other in the correct order. That's why I had to do the robot's left leg first, and then the right leg will be next. And in my case, this pink wire, which is going to be joining the batteries together, has got to run down through here, so we got to get this battery out of the way. Get that connector out of the way. It's just easier to tuck this wire in before you put the leg on. So over the motor, and then like this. Grab a couple of the nails. I might as well put the E6000 on there now since I know I'm going to do it that way. I could have screwed them. It's like I did the other one. You know, if you didn't have finishing nails, if you didn't have number 2 screws you could just use jumbo paper clips. Run the jumbo paper clip all the way through and bend the ends over. Just anything, it's just an axle. Just anything to hold the leg in place that allows the leg to move freely. There's nothing too sophisticated there. Maybe you've got some other piece of junk wire laying around from something that would work as a good axle if you didn't have nails or paper clips or anything else. There we go. Alright. In my case, the red and the black wire are going to tuck up through this little slot. We kind of talked about it earlier. It's just a way of routing the wires to keep them from, keep things a little bit neat, keep them from going where you don't want them to go. Just like so. And you don't want to pull them super taut. I mean, you want to make sure that everything can move freely down here. Same way with the wire that's verging from one leg to the other. You want to make sure that you've left enough slack that everything's going to move just fine. I can see that we have pulled the red wire hard enough to dislodge the contact in the front. Normally I would have, you wouldn't be doing all this in rapid fire like this. You'd let stuff glue and dry and set up. So now I'm getting a rough idea of how long the wire's going to be where it connects. We finish our connection here. I think that'll work. And let's strip that back. What I'm trying to do here is pull off some insulation on the end of this wire. Well, if you're looking for a source for small wires like I'm using here, one of the best places to obtain that is just any old computer cable. You find an old computer parallel cable or serial cable or printer cable. Any old computer cable that's just garbage these days because no one uses them. Just slice them open and you'll find there'll be a big bundle of these little wires in there, and they're perfect for this kind of job. So we got a little solder on on the end of that. And get the solder on there. Find a place to put the soldering gun where I don't melt something I don't want melted. And let's put some glue on that connector and stuff that battery in there. I really should have found some batteries first that I knew were even good. The shelf that I grabbed these off of is normally my shelf where I keep the batteries that I'm pretty sure are about half dead. And you're going, why do you save half dead ones? Well, I don't know. I guess I just don't want to throw them away when they still got some juice left in them, you know. Alright, so that battery should hold that in place while that dries with any luck. Alright, now on the front, we have these coming around now. There are two cam parts. We're looking at this cam part right here. This prints flat, no supports, and we're going to push it on with this big round part outside, and we simply have to line it up. One with the flat on the shaft of the TT, and then two, if you can see that, two, and line these guys up so when I push it in they both get on the same cam, like so. I think I'm all the way in. Feels like it. I guess I could test that. If those batteries have any life at all, I should be able to strip a little bit back on these two battery wires. And if I just touch them up here to the motor contacts, if it comes to life, then we know a couple of things. One, I got the cam right, and then two, we got the batteries are right. There we go. I can't really hold all that. Just trying to get where you can see the cams. But it's working. So we may get fresh batteries before we go too far with it. Now there's going to be, oh Lord, okay, there's going to be another little cam. This flat one prints like that, no supports. That's going to be in the end, theoretically you'd want to glue it onto that one with this post sticking out. But here's where you make the choice of whether you want, when the body is tipped, let's say to the left, I know it's the right side of the screen, but that's the robot's left. Do you want the arms then to swing to the right, so they swing the opposite way the body swings, or would you like them to swing the same way? The white robot that I showed you at the beginning, I had the arms and the legs moving in opposite directions, and the way you would do that is if this cam, large cam up here that's hitting that, right now it's near the top, so if I wanted them opposite, I would put this onto this shaft and glue it in that position so it's on the bottom. But if I want everything to move the same way, I would put them on that way. I'm not going to glue that at this moment because we don't know what it's going to look like. I've never looked at it that way. I just assumed I would want the arms swinging the opposite way that the body swung. But who knows? Maybe it actually would look cooler swinging in the same direction. Okay, so part of that arm swinging thing is there's this post that's going to hold a pivot shaft, and we're going to hold this on to those two motor screws with the 632s like I talked about earlier, even though I've dropped one and lost it somewhere on the floor. I'll find another one. And I think maybe it would be easier, here's the pivot shaft, this is going to ride on that little pin. I think it might be easier to press that on with the nail right now. Not 100% sure. Let's see if I've cut a nail back to roughly about the right height. I'm going to hold that there and there. I think so. So you can see the nail fits through this one, and everything fits nice and loose. And hopefully when I try to put it into this half, it should fit nice and tight. Feels pretty tight. I'm going to use some pliers just to squish it on down. Trying to go in sideways though. I don't want it going in sideways. There we go. Not so tight that that binds up, you know. Just, yeah, that's a little too tight. Yeah, now it's a little bit too loose. Don't tell me we're getting there. We're getting there. That'll be just right. So we now have a mechanism that looks sort of like this. It's binding just a little, but not too bad. And it's going to sit onto this contrivance like that. And I do still have one of the 632 screws. It's going to go there. Thread all the way through into the TT motor. And got to look for a replacement for the one that I dropped on the floor. So I'm digging through my box of miscellaneous screws, and yes, there I do have one. Grab that. The reason I got so many of these 632s is at one point the entire house got rewired and replaced all the outlets and wall switches with new ones. So the old ones, before throwing them away, took all the screws out of them because I knew they were very useful 632 screws that could be used for something someday. Alright, so now we have that contrivance on there. Let's see, what do we want to do next? We can, something that may need to dry and glue we can mock up next. We talked about this shoulder part already and how I mounted the switch in there, but there's this neck piece here, and this neck piece prints this way with no supports. It'll print fine, but this little hexagon part here, the smaller one, this is going to glue into the top so that it's sitting on the robot like this. This is the front. You want that spacing area towards the front. So I'm going to take some of this, weld on number 16. You say if you don't have the weld on number 16, just go ahead and use your super glue. It's just not as good. It's not as permanent. With temperature changes and stuff through the years, it can, in fact, in most cases, will let go. It's just a matter of time. You know, as thermal things happen, they expand and contract based on the temperatures in the room. The super glues will eventually crack loose and let go, especially when you're going between dissimilar materials. So now we can let that set up for a moment. There we go. I'm thinking we need to do some wiring, or we can do some arm work. Let's do some arm work while that's drying. So the two arms are basically the same. You can just flip one over, one becomes a right and one becomes a left. This would be the little hand part. This is like an elbow, and this part goes up at the shoulder. And this shoulder one has a little bit of garbage in it. I'm going to clean that out. So they print flat with no supports. And we're going to pin those to this bit of linkage that moves them, or is going to move them, or cause them to move. So again, I think I have some nails. Some nails that I've cut down for that here somewhere. There you go. And again, I'm hoping that I can just press them together. Now the way it's set up is the nail should pass through the arm part freely, a little bit sticking out the bottom, which is then going to get driven into this part. This part is a little bit of bugaboo from the printer. There we go. And the way this part fits is this bulge goes to the front away from the robot, and the lower part is the top. So you would take an arm in that part and basically place them like that. And again, why not just use the pliers to press that nail down in there. There we go. And just do the same thing on the other one, only making sure to flip the arm over. So we now have something that should look sort of like that. These are going to be anchored up at the shoulder, and these are going to be down below. Let's see. The head, I think we need to deal with the head a little bit here. What part of the head tipping stuff has to do with this little piece, which prints flat with no supports like this on your printer. It has a hex opening there, and we have a hex shaft which prints flat on your printer this way for strength, because that way your layer lines are running the length and it'll be less likely to snap. Plus, when it fits into the other hex openings, let's see if it has one end that it favors. Yes, it does. Okay. So I'm going to take this and I'm going to press it into here, and I'm just going to go ahead and put a little bit of the weld on number 16 on the very end of this. I don't know that it even needs any. There we go. I don't want it sticking out past the front. So we've basically made this. I don't want that, any glue that may have oozed out there, becoming a problem in this next step. Because basically what we're going to do is just going to take this part, and it should fit right through this neck like that, and it should be free to move. But before we shove it in all the way, this slot in the center, that's where the head's going to go. So there's also openings where I can run these wires. I'm going to go ahead and shove the wires in the case of my LEDs that I put in the head. Again, that's an option. You don't have to do LEDs in the head, but we can line that up like so, and then push that in. I'm pushing against the wood here to try to get that all the way in. There we go. Say, the LED eye light thing, that's just an option, and it's just one more thing you have to fuss with. I didn't really cover that because I figured if you know how to wire LEDs, you'll be good to go. But basically the two LEDs, an LED is polarity sensitive. It has a positive and negative. They're both wired in parallel, so the positive of both LEDs is connected together, the negative of both LEDs is connected together. Then off of that I put a single current limiting resistor. In my case I had a 330 ohm resistor laying around, so I stuffed that on there. because a red LED starts lighting up at about 1.8 volts. It depends on the LED, but point is less than 3 volts. So unless you put a current limiting resistor on there, you're going to damage the LEDs. If you wired the two LEDs in series, the actual voltage that they would start lighting is above 3 volts, so they wouldn't light. So that's why you put them in parallel and a current limiting resistor. And the head is designed for 3mm LEDs if you decide to do it. And again, because you're only operating on a 3-volt system at best, you probably don't want to go in there with any color other than red, because the red has the lowest voltage threshold for turning on. You get like a white LED, and the threshold is just about 3 volts, like 2.9, which means unless your batteries are brand spanking new, they're not going to light. Or you could add a booster circuit to make them light. But in the end, we're going to end up using some of this space in here for wadding up the extra wires, because there's not a whole lot of space for any extra wiring, but you do want to leave wiring long enough that you can deal with it, work with it. Okay, so speaking of wiring, I'm going to bring up these wires on the back. You can see the black one, I'm just going to go ahead and plan on it running right directly to the motor. The red one will go ahead and run through the switch. Again, I could just try to cut and make this go directly there, no extra, but what if I screw up? So I'm going to purposely leave some extra wire on the black so that I can wad it up in that backpack part that I just showed you, in case something goes wrong. Something needs a little bit more wire than I thought it was going to. In the case of these LEDs, I think I made the green my negative, so I'm going to make sure I leave some that I can wad up around in there and then go to the motor, because it's going to make it a lot easier to solder if you're not trying to pull these things taut to each other. At least I hope I made green the negative. Seems like I would. Green's a very common color in America for ground. Kind of twist those two together if they'll stay long enough for me to put a little bit of solder on them. I'd already pre-tinned the motor leads so that it wouldn't be too hard to solder to them. You don't want to apply heat to that any longer than you need to. Alright. This may be off camera, but nothing I can do about it. I don't have a camera operator. And again, either you know how to solder or you don't. So here you can see that I've simply attached the black and the green, and again I plan on wadding up the extra. As far as the positive thing goes, it's going to go through the switch, so I know one of my LED wires is going to go to the switch. So let's just trim that up. Like so. And again, let's leave some extra. Save the part of the red wire that I'm cutting off now, because it needs to go between the switch and the motor. And this may be way longer than it needs to be, but we'll try to wad it up in there. Like that. And so basically I'm making a motor wire and the LED positive wire, and I'm soldering those two together, and then I'm going to run where they solder together to one of the poles of the switch. It's a standard slide switch that I've used in all my projects that I could find on eBay and I could find on Amazon. Basically, the mounting holes on the slide switch are about 19 millimeters apart. And of course, you don't even have to use a switch. There's no reason that you couldn't just put the batteries in to turn it on. You don't have to have a switch. So now I'm soldering the red wire to the motor. And the only connection I have left to make is the wire from the batteries in the feet, the positive one, red, to the switch. I know none of this part here is on camera. What can I do, right? I can try to tip you down a little bit, but I still don't think you're going to be able to see in there. In fact, there isn't enough room for me to get my fat fingers in there and the soldering gun. So I'm going to use these needle nose and see if I can't get in there. Like so. Alright, time for a test. I'm going to flip the switch. Okay. So we have the body action, and we have our drive for the arms working. Good. Now the trick is going to be to try and wad all of that extra wiring up inside the pack and slide this part down. Wires can go just about anywhere as long as they don't get in between where this part, where these fits the top of the body like that. I wish I had the screws, because it's nice to use the screws on the shoulder, because then you can pull the thing apart if you have to easily. Well, we're going to go ahead and do it this way, again using the nails. The nail should fit through here. Just try fitting a left arm in. I'd already pre-cut these nails down, not necessarily to the right length, but my best guess as to what the right length might be. I don't feel like I'm lined up yet. Seems like that nail should be further down than it is. Yeah. I'm not going to push that nail down all the way right now. One, I think it's too long. I'm gonna trim this nail up some. Nice to have some nice heavy-duty dikes for snipping something short. The hole in the lower part there doesn't go all the way through, but we do want it to go through enough. Like so. Let's see if I can finagle that nail to go down in there. There we go. I think I just need to trim this one on the other side a little shorter. I think it's just a little too long. Let's have a look at how that length looks. It could still possibly be a little bit long, but I'm going to try it. Again, if you didn't have the nails, you didn't have the screws, you could use a paper clip and put some super glue down in that bottom hole or even on the top shoulder. In fact, it'd be easier just to glue the head of the nail up here in the top shoulder, but just glue the whole shoulder piece down in place. Okay. You know what we haven't done is there's this piece for the top of the head. It prints flat like this. So obviously this indent part is meant to go into the head. It's just a lid. I didn't look. Did we have LED lights happening when the motor was running? I don't remember. Probably should check that. Yes, we do. Okay. So, got the top of the head here. Again, hopefully the glue doesn't take too long to set up. Now, what's going to connect the head and these arms and everything to that is, again, we're going to take a piece of a nail or a piece of a paper clip. There's a hole in the end of this piece, and you should be able to just stuff it down in there. And once you've got something the right length, I just saved one of the pieces of the nail that I'd cut off, and we're going to try that, and if it's not right, then we'll have to cut another piece. But these pliers are a little bit big for what I'm trying to do here. Trying to press the nail down into there, and you'll see here in a second. It could go down a little bit further yet, but I took the nail, passed it through the hoop, passed it through the hole for the arm, and into the end of the shaft. So when this shaft now moves, we now have all that action. So I don't know, is it the this part down here that we didn't glue on because we didn't know where we wanted it? Obviously it was just slipping. That's why everything stopped. I guess I'm gonna have to glue that. It certainly would have been easier to do that earlier. Let's see. I'm just going to go ahead and take a chance and glue it the opposite of the white one, just to see what it looks like. I'm just going to put glue in 2 little drops. It's not too easy to get that in there now that everything's already assembled. I should have just made that decision in the beginning and glued it and been done with it. Now, having said what I was going to do, I just glued it the same as the other one. Alright, let's flip it around. I want to see it running the opposite. I want to see what's better and what's worse. Get over there. Sorry that it's not on camera, but I'm fighting with stuff right now. Fighting with a lot of stuff right now. I think the glue is already dried up and I still haven't got the cam in place. Let me get that on there. Got to remove this pin because it got out of place. Come on. Thank you. Pin out. Let's make sure. Okay. Now let's put the pin back in. obviously the pin will need to be glued in the end. Alright, let's try that. Yeah, so I don't know what's wackier. Let's get the white one down here. Take the sign off the white one. To hang them, you can just make some little hooks out of paper clips just to hang the signs. So now we should be able to see where the arms are moving the opposite direction of the body swing, and when the arms are moving in the same direction as the body swing, which one looks more crazy. I don't know, I kind of like that better. I haven't glued this one yet either, so I may take that apart and glue it the other way. Kind of looks a little bit more wacky. Both cases, they're both running on old batteries. I think I can get a little bit more dancing speed out of them with some nice new fresh batteries. You want to see the mechanism from the side or from the back. The TT motors also come in single shaft versions, which would work fine. The only thing I had laying around in my junk pile was the double shaft. So the other shaft's just sticking out the back there. So now you can see how this ridge part helps hide the wires that came through. The extra wires are bundled up in there. Gives you room for the switch. Yeah. So I think the only thing that I'll change on this is I'll make sure that I get this little metal pin properly secured down in there, and I think on this one I'll have to flip that cam around so that it dances more like this one. I kind of like the way that looks better. Alright, that's it for the build. Files should be up on Thingiverse shortly if they're not already.